Hello, my name is Hauka. I'm working in Riga Technical University, researcher. I'm here today to talk a little bit about monitoring system. This presentation is part about the scientific project where my goal is create the monitoring system for constructions or for, by example, airframe. Why we need this systems? We need because the maintenance is expensive and we must take out some object. By example, we must take aircraft from operation and only then we can take this testing. If we integrate our monitoring system, then it can give some pluses or improve some safety problems. How to do that? I propose to use the EMI systems, electrical impedance systems. That's the non-destructive testing, one of the non-destructive testing systems. What's good here? Here can we use only one single piezo element and get out the necessary results. Okay, what we can see here on our presentation. On the left side, we see this EMI element. And the right side, we see what really we can now get of the system. We get frequency and resistance. About this fingerprint, we can find if something is changing in construction. If this fingerprint is changed a lot, that means this object is something happening. By example, it's a growing crack or another breaks. By example, something is broken on the parts or the elimination in composite materials. Okay, how the system must look like? We can see here some example of the system we can try to use, by example, in aircraft. In aircraft, we can try to use Wi-Fi systems. That means the system together will communicate using some wireless technologies. Why I'm using wireless technologies? Because wireless by itself is a lot of weight. And that's one of the ways how we can use. But we get here one small problem. Each of the elements must get the individual power supply. That means if the system can get this power supply, then it's great. But if we must attach it, then the system gives some problems. Okay, what we can see? We can see the PCT. PCT, that means it's a piezo element. This piezo element is for this main sensor. And the sensor can give out elements. EMI unit, that's the same unit who measures this element. Single board computer. Here we can use single board computer or we can use some microcontroller. Here's no big difference. Single board computer pluses we can use advanced encryption technologies. That means it's more safer for using. That means no one can interdict it. And we can use a multiply these elements. That means we need a lot of them. 1, 2, 3, 4, maybe 20, and that's all information can be then stored in the server. This server will be responsible for making some filtering of the data and looking what is changed or not. Looking on the old data, compare it, and using this we can get out some information and we need this take out of operation this object and make repairs or not. This is Wi-Fi system. Here's the second one. It's already wired system. It's more reliable, and it's what I'm trying to do now in this moment. This wired system now need for a lot of power sources. We can see here see only one power supply, and we use PoE system. This is PoE. That means power over Ethernet. That's unlock possibility to use only, by example, internet cable to feed out our boards, and that can get to some point. Here I use a standard switch system That's increase the price, because no need for making something new. We can use already existing systems. And the system, how they work, is absolutely the same. That means we again get this element, like sensors. We can get one sensor from the same ME unit. We can get it 4, 5, 6. That's not a big difference. It's possible to do that. And then we get this ME unit, single board computer, and throughout internet cable it go to the switch, and switch already go to the server. Now we can use the server data for getting some samples and so on. Next, about the piezoelectric piezo sensors, we can see here on the left side, yes, we can see one element what I already use. It's simply small plate, nothing more. It's a ceramic plate. This ceramic plate we bond to the surface. Its surface can be metallic surface, it can be ceramic surface, it can be metallic, composite, whatever. And using these sensors, so ME system, to measure impedance. Yes, this impedance can change it by some vibrations and so on. That means we track everything. By temperature, we must take vibrations, and we track a lot of information, and everything must be stored inside the server to not get out of error. And the right side, we see already some test example. On this test example, we can see bonded element and cable. Okay, this element can be attached to our ME unit, and we take this out the data. It's the same we can see in this test object. We can see it's already with crack and without crack, and then using these two parameters we can find its working system or not. Yes, it's working, of course. Next, about small board computers. Why are we using it? I want to use it because it's in this moment. It's already very cheap. And we can use, by example, Raspberry Pi Nano, Raspberry Pi, or Orange Pi. Here we can see 3 different systems. Raspberry Pi is one of the expensive. Raspberry Pi Nano is expensive too, but here it's one big problem. Why these 2 boards is not good for me? It's about this PoE. That means I need this PoE possibility. That means better to not create something new, but rebuild already existing thing. And of a lot of computers on the market in this moment, I use maybe not the youngest one, but newest one, but enough good computer. By example, this Orange Pi computer. Here we can see what is good here. We can see the internet cable connection. This internet cable connection get 2 outputs, PoE plus and PoE minus. And these 2 outputs is connected directly to the ground. Of course, to these resistors we are removing because 75 ohms resistor will burn out immediately if we use higher voltage than 5 volts. Second problem here about these small computers, they all work only with 5 volts. 5 volts for us is not enough. We need more energy for feeding our ME unit and for feeding the long distance wire, because we are losing a lot of energy in wires. That means better to use higher voltages. That means we must remove these resistors and replace, by example, with some voltage level or voltage stabilizer. And by example, in this moment I use 5 amperes 40 volts stabilizer. That means we can already operate this element with long distances. Yes, we lose some energy, that's true, but it's good way how to do that. And that's already, we go to the end. Okay, this is our prototype already. And with the prototype we can see with the numbering, number 1, it's our computer by itself. It can be used by wires and can be used like wired. In ours, this is my experimental model. We can use both way. We can use it in by output energy. Does it mean external energy source, or internal energy source. That's no difference. It can be powered by solar energy. It can be powered with big battery. We can use this battery and, by example, make maintenance one time in a year. Replace the batteries, and again, this unit can work. But this is already better for infrastructure, not for, by example, aviation. Because aviation, we can use already board voltage. We can get the one. Second is our voltage stabilizer. You can see it. Second one, and it's connected directly to our board, and it's connected to our board with number 3. It's like power distribution board. Its board is responsible for distribute power between our orange P computer and the element 4. That is our impedance measuring unit. Yes, and this communications protocol I use is integrated circuits. It's an E2C system. It's already very popular. It can manipulate in very long distances, but whatever, it's not our problem. But we can put a lot of elements in parallel. That means the sensor can be 1, 2, 3, 4, 5, and that's absolutely not a problem. With element 5 is keyboard, it's temporary. Maybe in our product we can already get this keyboard too, but in this moment it's like temporary to change some parameters and not go to the program. And the last one, 6, it's some additional sensors, like in this way. Here I put the humidity and temperature sensor to get some relationship between the signals. And yes, they will be changed by temperature, they will change it by everything around, and it must be tracked to get the correct results. About conclusions, yes, the next step is real bench tests to get output and get how clear results we can get out. Yes, we can get some results we already test in the laboratories, but we must already make some objects, for example 5, 6, and start look how it's working in real life. Connect it and the system, and that's already will be important step in my project. That's the thing. Yes, you can use LTE technologies. It's true. Why not? Communications module we must simply add, because we use a single board computer. We can add the separate module and make it like you already work in LTE. That means Wi-Fi network not necessary. That's it. Any Wi-Fi or wireless technologies will be acceptable. That's the main conclusion. And all this, that's really all what I want to say.